Hey everybody, it is Tuesday and we talked about balancing equations in class. I'm going to go pick on my friends here in first period. We're going to start there. So as always, the recording for the lesson from the day before is here. So underneath this one will be today's. When we start the day's class, in materials is our do now and the daily slides. And I'm going to publish tomorrow's do now so it's ready for my first period friends. All right. And then, as always, anything we grade is here. Yesterday we had a Counting Atoms quiz, and right now we're going to work on their digital notebooks. So you could click here and they can open their digital notebooks. It looks a little different on the student side than the teacher, but I am going to click on today's daily slides. So in the daily slides, as the diagram shows the force acting on the toy car as it moves to the right. Which diagram shows the toy car that will most likely accelerate to the right based on these conditions? And as everybody looked, they noticed that the greater amount of force out of all of these to the right was here with car F. Now number 2, strontium phosphate, SR3PO42, is a crystalline substance used in medicine. How many phosphorus atoms are in the formula for SR3PO42? So remember, the subscript gets applied to just the O and the P. So 2 times 1 is 2. That's awesome. So today I will determine if a chemical reaction is balanced by comparing the amount of each type of atom on the reactant and the product sides. I can identify what's the reactant and what's the product. I can count atoms, we've done that, and I can compare the numbers to see if it's balanced. But before we do that, we're going to do a quick little review. These are yesterday's most missed questions from the quiz. How many atoms of nitrogen are there in the chemical formula below? Well, again, here's the subscript, so I have 1 times 2, and I'm only concerned about this, so that's 2. This question, how many atoms of beryllium? So if we looked up on our periodic table for beryllium, we notice that Be is, and how many here? We have just 1. Got some really wild answers. But here is the things we want to talk about today in class. And I'm going to check a little version history here. Okay, so the first thing is what is a chemical equation? It is a representation, and this is slide 14 in your digital notebook, is a chemical representation of a chemical reaction. And you know what? I'm going to go open my notebook. I'm going to go get my notebook. So hold on. Now, you should have yesterday graphed your quiz results right here on slide 5. So no matter what you got, you'd graph it here. Okay. We're going to come over here to slide 14. Just a quick reminder that, remember, we multiply only the items on the inside by the coefficient. So here, copper isn't, but phosphorus and oxygen are. So here are some definitions. We completed them. A chemical formula is a set of symbols that are in proportion and may also show the molecule shape. Like water, a chemical equation like 2H2 plus O2 with the reaction of 2H2O is a representation of a chemical reaction. It will have reactants and products. I'm also going to add here, we're going to add to this, there will be a plus between reactants on the left, then an, oops, sometimes we get goofy, then an arrow pointing toward and separating the products. Okay. And then on slide let's see, this would be, let's see, we said 14 or 13. This would be 14. And we're just going to check that here with our notebook and our slides. So yeah, so we're now here. This is slide 14. So this is slide 15. So we're here and we're looking at the reactants. So we're going to drag and drop. Reactants are here, arrow is there, our products are there. Reactants, the input into a reaction is on the left side. The products or output are on the right side, and they are produced after the reaction and are a new substance with different properties. So when we balance these equations, we want to make sure we have the same amount of stuff on both sides. So conservation of mass is the amount of atoms in an equation does not change from the reactants to the products. Conservation of matter is the type of atom in an equation does not change. So key idea is in a chemical reaction, nothing is created or destroyed, just rearranged. And we see that here. So what we did is, and I'm going to go back to the slides so you can see this a little better here, is, oops, it's going to do the same way, so let's go to our slides, is list them out. So we listed out the phosphorus and oxygen on both sides. Were there other elements present? Nope. Then we can keep going. Count the atoms. So P had 4, oxygen had 3 times 2 for 6. There we go, 4 and 6, because I have 6 and 6 oxygen and 4 and 4 phosphorus. Are these balanced? Yes. And then mass is conserved. We did a similar one here. This is on the slide. And we determined that we had 1 carbon and 4 total hydrogen. 1 carbon and 4 total hydrogen. So they were balanced and the mass was conserved. So that's where we're going to stop today. We did some more practice problems. And if you're concerned about these, there's a number of slides here. And here, we wanted to go through all of these and say they're all correctly balanced except, that's right, you got it, our little friend C. Because I have 2 hydrogens when we do this all out here, and I will actually have 2 times 2, I'll have 4 hydrogens, so C would be the version. All right, friends, I just want to tell you I hope you have a great day, and that you enjoyed, restore that, and that we see you all on Wednesday and Thursday.